Hi there, since this is the month of Dosember, I thought we might have a look at x86 running on ARM, or more correctly DOS running on an Acorn computer. Not just any Acorn computer, but this Acorn A3010. My father bought it as a family computer for us in Christmas 1992. Previous to that, we had a BBC Micro as well as an Atari ST. I think something that always interested him when purchasing a family computer is that they had some degree of IBM PC compatibility, so that documents could be brought back from work and edited, since a lot of work was done on IBM PCs, and by 1992 they could have been 286s. This Acorn A3010 was supplied as standard with high density floppy drive. There was no hard drive fitted and 1 megabyte of RAM. The processor inside is a ARM 250 chip, which is, at the time, there was an ARM 3 processor and an ARM 2 processor. And the ARM 250 chip was an ARM 3 processor, but without the cache memory. And it also had I/O, video and memory controllers integrated into the same chip silicon. So it was effectively a system on chip. And this was going to be used in this range of computers to bring the cost down. Having said all of that, this is one of the early production models, which was made before the ARM 250 chip was actually available for production. And so what they did was they created a sub PCB called the mezzanine board, which has a processor chip, the I/O memory, video controller. So these are all separate chips. That little module was codenamed the Adelaide board. So they probably actually made it quite expensive to produce this item, as opposed to the plans of a integrated ARM 250. Okay, well that's enough about the machine. Let's get it powered on. And it will boot into Risc OS 3.1 operating system that's stored in ROM. You might not be able to hear it, but the power supply, which is built internally in here, which is a large transformer, and there's linear and switch mode output stages in the power supply, has quite a 50 Hz hum to it. Back in the day, when this had a mechanical hard disk in it, it may not have been quite so noticeable because it was quite noisy, but now with a solid state hard drive, you can certainly hear the 50 Hz hum, and you can even slightly feel it on the desk. So that certainly takes me back to using this, in the past. Okay, so now we've booted up in Risc OS 3.1. Something to note is that the output of the Acorn is going through a video conversion device called the GBS, and then it's getting captured by a Elgato video capture card, and the whole setup is quite fussy about the input resolutions and the way that the video is converted. But the picture quality looks quite clear at the moment. One of the adjustments I'm going to make is just to move the picture up a little. Okay, there we go. And so now let's open the hard disk. And under this utils folder, I've put Acorn PCEm, which is Acorn's PC emulator. This is the final version that was produced. It was version 1.8, and it was released in '92. The application is split into single tasking as well as PCEm multitasking application. The multitasking application allows you to run the PC emulation as a window on the desktop, whereas the single tasking will run full screen. The other thing the multitasking version does is do VGA emulation. So it's certainly a build of the program that's designed for Acorns with a lot more RAM. This Acorn has been upgraded to 2 megabytes. So I'm going to go into the single tasking version and open this up. And the icon is down here on the taskbar. And you can set some configuration of the emulation. And at the moment, there isn't any hard disk drive files. So if I click here, it sets it to 1. Now, one of the things that took me a little while to get right was that actually PCEm is quite fussy about having the full path of the hard disk file that you want to create. So I actually want to put the hard disk file in this folder here, and so this is the path at the top. IDFS, ID disk 4. Dollar is the root or the home folder of the hard disk. So I'm going to put it in utils PCEm. I'm going to call it drive C. And I'll make this 10 megabytes in size. So now I've got that all set up, I can click on create. And the PCEm application is currently creating the hard disk drive file. Okay, so now here's my hard disk file that's created. I've actually already created a drive D, and I've put I'll show you what I've put into this. So I'm going to put that there. I need to change this to 2, and then instead of this default location, I'll put in that one. And now I'll save my changes. Okay, so now I can start the PC emulator just by left clicking on it. And what it's saying here is it's booting from a non-DOS hard disk, so that partition that we just created is actually blank. So what I've got is it's called this was made back in when the system was used. We just called it the IBM system. So I put that in, and it will boot from floppy. And there we go, we've booted DOS and running that on this. So if we look at DR DOS or Digital Research DOS, version 3.41. On C drive, have a look at the... yes. So this C drive is actually the D drive that I set up in the configuration. It's changed the D drive to being C drive because the C drive that we created doesn't actually have a partition. So let's, I'm going to change to the floppy disk, to A drive, and run fdisk, which is the fixed disk partitioning program included with DR DOS. Okay, so here it's saying the first hard disk that it's found. The first hard disk sector 0 doesn't have a boot ID, so let's initialize the hard disk. And here it's found that it's 10 megabytes. So let's create a DOS partition, a primary partition, use all the cylinders, and it will start creating that partition. So this is going to take a little while. I might actually speed this video up once I've made it. Okay, so that's that finished. We can enter a disk label. I'll just leave it blank. Escape to exit, and it's saying that the operating system needs to be reloaded, and it's going to start from system disk in drive A. So let's just go along with that. We'll see what happens. Okay, so the system has restarted. It's loading DR-DOS from the floppy disk. And now we're dropped at this C prompt. So let's look at the directory listing of C. There's no files, and there's just over 10 megabytes or 10 megabytes free. And on the A drive, this is our DR-DOS system. And in fact, the files that I copied onto this D partition that we configured at the start is actually the files for setting up MS-DOS 5.0. Because I'm not so much of a fan of DR-DOS, I wanted to install MS-DOS. But what I've found is that if I run the setup, it actually asks me to insert, it only wants to install MS-DOS 5 from floppy disks. It's not happy to just copy the files across from D drive. So what I'm going to do is I'm going to use sys to actually copy just the system files from D to C. And that says that it's transferred the system. So now if I remove the floppy disk, we should be able to do Control-Alt-Delete, restart the PC emulation, and here we go. We've booted off from the hard disk file that we created. So MS-DOS 5. And again, there's only just the files required to get MS-DOS 5 booted. On D drive, these are all of the installation files. So something that is very useful about Risc OS 3 is that it also has support for IBM DOS type partitions. So these files that represent our DOS disks, drive C and drive D. In fact, we can actually double click and open them and see all of the DOS files that are contained inside. You can only do this, you can see the contents when the emulator is running, but you can only actually change the contents when you have closed the emulator. But what I'm going to do is, because I can't install MS-DOS 5 from a hard disk, I'm going to copy over the files of a new MS-DOS 5 installation. So let's start connector, which allows me to transfer files using a Z file transfer from the PC. Communication. Oh, that's wrong. Let's change the baud rate. Okay, so now that is finished, we can close this and we can open the downloads folder. And here is our DOS5 installed files. It has actually truncated the name. So let's open our drive C and copy this into the emulator. Okay, now that is done, we will close that. Let's go into the single tasking. Run the emulator again. Okay, so here is DOS5 install, and let's rename that. And we're going to make a directory called DOS5, and using pk-unzip, which I've got on the D drive, we'll include the directories. Unzip that. Okay, so let's create a DOS folder. We'll move the DOS5 utilities into that folder. Does it move? Move. Do a copy. And let's edit the auto exit back. New save as auto exit back. Okay, so we'll turn the echo off, and we will change the prompt to being the traditional. It's $1, isn't it? It's $1, P, $, I think it was G. We also have to set up path. So now if we reboot our system, okay, so now we've got a good path, and DOS utilities should be available. Okay, so our DOS 5 is now operational. We're going to make a directory called utils, and we'll copy decom back to pk unzip to utils. pkunzip.exe. And let's edit the auto exec back to also include utils into the path. I think it's a semicolon. Restart the system, and at the prompt we can use our pk unzip. Now, one of the things that DOS 5 doesn't have is tab completion, which is a bit of a shame. But I also copied a landmark, so let's make a directory called landmark. We'll pk unzip landmark.z. Mark. I think this has directories in it, so we'll put in a /d. Excellent, so now we've got the tools to benchmark the system. Well, the zip already had a landmark folder inside. Let's run landmark. Alright, so get ready for astounding performance. Huh. That's quite interesting. It reckons the floating point operations is equivalent to a 5.9 megahertz IBM AT, and the CPU is a 2 megahertz PCAT. Has it crashed? F9. I think it has crashed. Video performance is of course terrible. Press Control Delete. Okay, so that was the landmark test. Try speed. Okay, this is another version of Landmark, version 6. Now we get 30 characters per millisecond video. FPU 2 megahertz, CPU 2 megahertz. Again, it has crashed. Right, Control Delete. Okay, well I'm going to go and have a look for some other benchmarking utilities, I think. Okay, so I think I've copied over some benchmarks. I'm going to make the DOS screen a little bit bigger so we can see what we're doing. And let's make a directory called check it. And we'll pk unzip check it. Let's rename. I know Adrian Black from Adrian's Digital Basement quite likes using Checkit 3, so I had a quick look online for Checkit 3. I think this version is actually in German, but we'll give it a go. Okay, so let's run Checkit. Yes, there is a bit of a problem with using the version in German. Oh boy. I think I have to see if I can get the version in English. But this looks like it's doing some tests. Right, exit DOS. I think I'm going to go and see if I can find a version in English. Okay, so let's have a look at QBasic. Open. Now, I seem to remember there was some games included in DOS 5. Wow, so this is taking quite a while to pass nibble.bas. Okay, so we've opened nibble.bas. Let's run. Is it playable? One player. Ooh, skill level 50. Increase the speed. Monochrome. It's looking more like basic isn't really an option for running on this emulated DOS. Oh, well. Push space. Hey, it's quite playable. I don't know if this is the speed that it's supposed to run at, or oh dear. Right then. How do we quit? Control C, Control Q, break. course, Control-Alt-Delete. Okay, so what I've done is I've actually typed in a little program which was it featured on a Knowles Retro Lab, and it's just a small DOS program that runs up an accumulation, and what we're going to do is we're just going to time how long it takes. So there it is loaded. I think also Adrian Black has done this recently on a IBM PC compatible, so we'll have a look at the time. We'll have to add a stopwatch into the video. Okay. Just for comparison, let's do the same thing in BBC Basic. Quit this. And what you can do in Risc OS is you can, let's open up this DOS file, just put it here. I'm going to go into command line mode and I'll go into basic. It's slightly falling off the bottom of the screen, isn't it? So 10 for I equals 1, 2. Print S. Okay, run. 1, 2, 3, go. Done. And do start quit. And then we go back to the desktop. So there you go. Certainly applications run a lot faster natively or in the ARM BBC Basic than an emulated environment, but that's not a surprise.